Hello everyone. Right now I'm going to tell you how do we use R for neural network time series forecasting. And first I just explain how do we use R for neural network model building, especially for time series data. Followed by this, in the second video, I'm trying to explain how do we use parameter tuning using R and get the optimal parameters. In order to run time series forecasting using neural network, I need primarily three different packages. Let us first install these packages. And I believe all of you got these packages in your system. The packages are tplyr, ggplot2, and forecast. And in my case, the packages are already there. Hence, I'm not installing these packages again. Rather, I just activate the library of these packages. Let us actually get the library. So I get the library dplyr. Then I need the library ggplot2. I need library forecast. These are the three libraries I require. Let me activate all the three libraries. I have activated these libraries. And next task is to read the data. And I believe you are familiar. We've been discussing about the data during the past classes. The data is DHS Daily Report 2020. Let us read the data. And I'm just giving the data name as df. And I use a function read.csv. And before that, I just make sure that I have my working directory active. If I'm straight away trying to read the data, I need to make sure that my working directory is active. So in this case, and let us actually activate the working directory. So here I have the data in my one of the directories, and I believe I have the data in this. Let me check whether I have the data in the directory. Yes, this is what the data, DHS Daily Report 2020. So I use a function read.csv. I use DHS underscore daily underscore report underscore 2020 dot csv and make sure that is in quotation so that you'll not get any trouble in terms of reading the data. And this is what the data which we are trying to use for time series modeling. And I believe you are familiar with the data, and because earlier classes we have discussed this data with respect to running Facebook Prophet, Adima, Sarimax and all. Okay. If you see the data, you can see the date column here. The date column is in, if you see the structure, let us see the structure of the date column. Structure of date, D capital letter here in this case. So I just use str df dollar date. So if you see the structure, you can see it's a character vector. So if you would like to use this date column in terms of any visualization future, and we need to make sure that we converted this particular column as a date column. Okay, so in order to convert the same, let us try to change the format of the same. So let us convert the format of the date column as date vector. Is it? Now what I do, I just use df dollar and date, and I use strp time function, and I just mention my x data is equal to df dollar date, and I just use the format. The current format, if you see right now, it is in slash, right? So it could be more of month, date, and year. So I'll mention, it'll be, format would be quotation. So I'll say percentage month hyphen percentage day hyphen percentage capital letter Y, because there are 4 digits there. That's a reason. So after that, we'll convert df into as.date. I use the function as.date, and I can say df $date. So if you see right now, if you see the structure of the data after row, it got corrupted. Let us actually try in terms of doing what's a mistake. We will check it. So let me read the data again because it got corrupted. So I'll tell you the reason. The reason is that it's not separated by hyphen, it's separated by slashes, okay? So let me correct. It is slash separation. So right now, if you see the structure, probably it got corrected. Okay, fine. Let me change the column name. That is, I'm going to use total individuals in shelter as my dependent variable, that is y variable. So I just want to make sure that the column title be named as y, and so that is going to be my column names. So column number 1, 2, 3, 4. The fourth column, right? Is it the fourth column? And even before that, I just need to select the columns here. And I don't want to use all the columns. Let me do a selection. I'll pick up some selected column for my further analysis. Let me select the variables used for analysis, and I just need my df main. I just want to say df. I have columns like I use the dply function df percentage greater than percentage. So I'll use a function select, and I just select only specific columns. Date columns I need total individuals in shelter, so I don't need adults. I need Easter, and I need Thanksgiving, and I need Christmas, and temperature. These are the columns which I am going to use in my data for further analysis. So what I do there afterwards, I'll change the dv name as y. So here, if dv, if you see, if this is what my data, this is the second column, right? So I can use a function call names. This function I can use so that I can change the name of my df, where specifically second column I want to change it. I just want to make it as y. And after that, let us create a plot after that. And I'm using ggplot package, ggplot. Then I say df is my data name. I use a function aes, that is aesthetics. X is equal to date, and y is equal to y, that which is generated right now. And we can say plus, and geom line. I'm using geom underscore line, and plus xlab. I just want to say that it is time, and while app will be the vertical axis name is time, sorry, horizontal axis name is time, and vertical axis is, let's assume I make it demand. And theme here, before that I just need to give a plus, so just theme you select from here, and you say theme will be text is equal to, I just mentioned, you can actually start this way, text is equal to element underscore text. This option you can select, and I just say that size, and I'll just around size of the text would be 20, plus here the last, I'll say the scale would be, so I want to present the date labels, and this date labels I'll say it is, that representation would be, I would say, year space and this actually represent the label representation, the especially horizontal axis time represent, it will mention year and month, that is B explains that it will be in it'll be not in numbers, it'll be in alphabet. Okay, let us print it. So provide it in quotation, that's the reason we are not able to get the results. Yeah, so here this graph we are able to print it earlier, and we see that there is a trend, also possibly there is a seasonality here. That's what we explained, there is a recurring pattern as well as a growing trend up to a period 2019, after that slightly a decreasing trend. That's what we observe from this data. Anyway, let us proceed further in terms of model preparation. Okay, so here right now I'm just preparing the model with default parameters, and definitely you know that there are steps involved in terms of model building. So the first thing is that in model building process, before model building, so I have some process here, so I need to make sure that I split my data into train and test set. So here train and test set, let me decide, if you look at in this data, so I just want to make sure the last month, that is because we have data from and 2014 January 1st 2020 December 31st. I just thought of using December 2020 data as my test data, that is almost around 31 days data as my test data. So I do my splitting accordingly. So let me create training. So, and I can say df is my data, that is data frame. I can use percentage greater than percentage. So I can mention, I can use a filter my data. Here I can say date less than, I can say, and 2020. So 1201, right? So less than 2020, 1201 means until November end. Okay, 2020 we use as training data, and then we actually select the test data. Let me look at my test data, same thing, but here will be greater than or equal to this particular value, that is last 31 days we got as test data. Yeah, now probably we can think of building a neural network model for time series forecasting. Okay, fine. Before moving further with respect to time series forecasting, so we have a function here. It's called as NETAR, neural network autoregressive model. Let us look at neural network autoregressive model here, the functions here. So here we need predominantly some parameters, and I just use, since we are building a model without even tuning the parameters now, I just use what the default parameter. Before that, we need to understand what's the compulsory parameters. And one parameter, let us you know run the model. Thereafter I'll explain the parameters. Let me just type it as model, call it as model. Okay, so I call it as n net neural net autoregressive model, and I say bracket may be mentioned here y. Here y variable is your training data y, but the point is that uh, we need to have a separation between training y and test y. So in this case, we need to go back and do a separation here. Separate your regressors and here, before going to the model building process, we need to first make sure that we have converted our dependent variable, that is your y variable, uh, as a time series object. So we need to transform your y as time series object. Okay, so let us convert y as time series object. So let me convert it as time series object. So I just call it as training underscore y. Let me call it as, and I use a function ts which we used earlier. I say it is from my training data. The column name is y, and the frequency I just used is 7 because it's a daily data. And I'll give you some instructions here. You can mention 7. You can specify 7 if it is a daily data, and mention it as 52. It is a weekly data. Mention it as 12 if it is monthly data, and mention it as 4 if it is quarterly data. So this could be the suggestion. Okay, in my case it's a daily data. Let me convert it as actually a time series object where frequency I just mentioned as 7. So I got it. Okay, so please proceed in terms of model building after completing this particular stage. I missed this stage earlier. Let me, okay, so not a problem. So we'll proceed with that. So what I do, I need one more steps here in between. I just need to extract the regressors, that is the external regressors here. And I just call it as training REG, that is regressor. It is nothing but, if you see, when I make it, I'll make it as a matrix, and I just want to select my training data, where I just want to use all my rows. And if you see my training data, third column, third, fourth, fifth, and sixth, all of them are third to sixth actually as my what I can say third to six as my external regressors in my training data, right? Is it? So I can say training. So I believe we are able to get similarly test reg is nothing but you can say as dot matrix. I can say test main, you can say all rows 3 to 6, that is 3 to 6 columns as my regressors here. So after that, I believe we can proceed for model building. Okay, so this step you should not forget. That is, first one is just convert as time series object, and after that extract the regressors, and after that we will do building the model. So I just build the model and I just use a function and net AR, that is using the forecast package. Here I need to specify y is equal to, what is my y? My time series object, training underscore y is my this one, and the parameters I'll tell you what is this parameter. P is equal to 1, and I'll just capital letter P is also is equal to 1. I'll explain it, just wait. And size is equal to 3, and my x or reg is equal to my training reg. So I have one more parameter here. The last parameter here is decay parameter. Decay, I just use a default function 0.1. Okay, so here I'm just typing the default parameter. I'll explain here. So here, as you are aware, y is equal to your dependent variable time series object, and p, small letter p is equal to 1 means while using or building neural network model NN time series model, we consider the lag of your of dv, that is called as AR, is it so? Autoregressive. Okay, and here we are considering the lag. Here we are considering non-seasonal lag, that is usual, because that we learned sometime before that in ARIMA we learned autoregressive, is it so? This is nothing but non-seasonal lag. Here we are not considering seasonal lag and rather non-seasonal lag. Then here's second P is here, the capital P is equal to 1. I mentioned that it is actually specifying seasonal lag, that is 1 is the default. That's the reason we are using it here. I'll put in hash so that otherwise it'll create trouble. And size, it actually mentioned number of hidden layers. So if you see, there is a suggestion usually, if you see my data, and my data, let's assume my data got 4 external regressors, and if you see Easter, Thanksgiving, Christmas and temperature, let's imagine these are my external regressors. I have 2 lag actually, so 4 plus 2 it would be 6, is it so? That would be the total number of regressors you are using. 2 lag parameters, one is non-seasonal lag, another one is seasonal lag, other 4 are external regressors, and this size actually specifies the hidden layers. And hidden layers, suggestion is that it should be less than number of regressors, including your just wait, including your lag parameters. So here default me I specified 3 as number. That's the reason you are able to get 3. Okay, and decay parameter is that if you see your exponential smoothing, we learned that how the lag actually, how we give importance to the lag, okay, and whether it is actually what rate may it is actually decaying, is reducing, right? So that reduction in terms of importance over a period of time is called as decay parameter, and I just specify the default one as 0.1. Let me run it and see the results. So I got the results. If I got the results, I can and build the prediction here. So I can use forecast. Then my model name is model. So my x reg is equal to my test data reg. I don't need to mention time period, but automatically captures the number of time periods here based on I will try to forecast. And I can simply make a plot here of my predictions. Now you can see this particular line actually shows that the prediction of your forecast. Let us check the accuracy of forecast. And I'll use accuracy. Then I say predictions, mean of predictions by test data may have y column. Okay, that could be your value, and you are able to print the accuracy measures. So if you want to store the predicted data, you can store the predicted data so I can say that neural, I just want to identify, I just use a function as.data.frame and I apply predictions $mean, and it will be your, it will convert as your data frame. I can actually write this particular data into CSV format. I can say neural is a name, and new name I would like to give is nothing but let's assume neural time series dot CSV. So let me look at it. In the prediction here, this thing we actually saved it into your CSV file. That's the way in which we save the prediction. And that's it for simple prediction without cross validation or parameter tuning, and we use the default parameters, and we will see the parameter tuning in subsequent video. Thank you.